Today we'll be talking about the fluids distribution inside the human body. And the fluids inside the human body can be classified into two groups. So if this represents the whole fluids of the human body, we can divide it into 2/3 and 1/3, like this. This will be the internal fluids, or the intracellular fluids, and this will be the external fluids, or the extracellular fluids. So the intracellular fluids are found inside the cells, extracellular fluids are found outside the cells. And the fluids that are found outside the cells can be divided again with the same ratio of 2/3 and 1/3. 2/3 of the extracellular fluid is found in the interstitium, or the tissues that are found between the cells themselves, which is called the interstitial fluid. And we have the plasma, or intravascular fluid, or plasma. So this is the classification of the fluids distribution inside the human body. Now, how does the exchange happen between the intracellular fluid and the extracellular fluid? We have something which is called osmosis. And let's suppose that we have a beaker, and inside the beaker there's a liquid, and here we have a permeable membrane, a semi-permeable membrane. So what happens is, we know that the fluids inside the human body are not just pure water, they have other particles. So these particles will be found on one side with a different concentration than the other side. So let's call this side A and this side B. If we say that on side A there are just this much of particles, and on side B there's lots of particles like this. What happens in osmosis is that the water will go from the side which has a lower concentration of the particles, or on the contrary, a higher concentration of water, as we can see, to the side with the lower concentration of water, or the higher concentration of particles. So water goes this way, like this, or let's put it in blue because black here is for the particles. So this is the direction where the water goes, and accordingly the level of water will rise on this side. This is how osmosis works. And based on osmosis, we have a couple of terms. We have something called osmolarity, and osmolarity is from the name is related to osmosis and moles. So it's basically the number of moles of the foreign particles that should be found in a solution in order to allow osmosis to occur properly. So from this term we have something which is called an osmole. And the normal osmolarity of the fluids in the human body is about 300 osmoles, milliosmoles to be more clear or more specific. 300 milliosmoles, not osmoles, that's too much. 300 milliosmoles is the normal osmolarity of the human body fluids. Or we have another term which will be millimoles, not osmoles. And this will be the half of it, because 300 milliosmoles will be related to the particles, all the particles. But for moles, this will be for sodium chloride, and we will see, because sodium chloride ionizes, so it gives actually 2 moles. So when I say 150 millimoles of sodium chloride, this will give us 2 types of ions. We have sodium, which will have 150 ions of sodium, and chlorine, 150 ions of chlorine. Sum them up together, you will get 300, the same number here. So when we say millimoles, it's 150, and when we say milliosmoles, then it's 300. And this number is rounded up. Normally it's 285 or 290, but it's in calculations it's written as a 300. So I hope it was clear for you. This is it for today, and until the next time, I thank you for watching and see you.